Hello everyone, thank you for joining us today for our webinar titled Getting Started with Consul-Terraform-Sync to Drive Network Automation, which will be presented by myself, Ilcha Markovsky, and Tony Fan, Senior Solutions Engineer, Consul Specialist at HashiCorp. So today, Tony's going to show us how by enabling dynamic service-driven network automation with self-service capabilities, organizations can solve typical day two challenges. Before we get started, just want to cover off a few housekeeping items. First of all, I'd like to note that this session is being recorded and the recording will be made available within the next day or two. We'll send you an email with the link so you can watch it in your own time again. Secondly, please submit any questions you have throughout the demo via the Q&A tab and we'll get to them at the end. So with that, let's go ahead and get started. So thanks again. My name is Ilcha Markovsky. I'll present a few slides to begin with, and Tony Fan is going to get into the demo and for the presentation in a moment. So before we get started, we wanted to give you the complete story of Consul. Right? When we look at Consul, it's been around for a long time and possesses three main elements to the platform, to its story. First of all, is that it's platform agnostic. And by platform agnostic, it's been designed and architected to enjoy multiple features across platforms. So when we look at its operation, it's native across VMware, AWS, Azure, GCP, and bare metal platforms. It has support for VMs, Docker containers, Kubernetes, and that includes upstream, OpenShift, Tanzu, AKS, EKS, GKE, and soon we're launching on ECS. And with that comes its operational simplicity and its ability to extend the control plane across the services that it manages. So programmability and extensibility through the API and CLI is important. It features ability to extend and enhance your workflows, automation, and self-service or processes. There is an official Consul Terraform provider, has a rich ecosystems of integrations, including Vault, Splunk, Datadog, Prometheus. Furthermore, it's a single binary. You can install Windows, Linux, macOS, FreeBSD, and Solaris. It can be via Docker image, Helm for Kubernetes, with plenty of platform guides available. And then the three main use cases that we see our customers using Consul for is, first of all, service registry to allow you to define and record and centralize all of your services, track their health and status in your organization. Secondly, infrastructure automation, which we'll cover in a moment. And thirdly, a service mesh to allow you to connect your services via mutual TLS, cross services, cross clouds. When we look at infrastructure automation, customers typically can assume that they're already doing that. When we look at customers doing network infrastructure automation, it's really two elements to it. There's the task automation side and the process automation side. Most customers kind of stop at the task automation side. And what exists is they're implemented redundant operator tasks in an automated script fashion, where on the other end, with the most feature rich is that end-to-end process automation that includes that end-to-end process from your consumer to the user of the process. And one of our customers, our clients recently said, it's not sufficient to automate your task. I want you to automate your customer's task. And if it's not automated from the customer's point of view, then it's not really automated. So let's look at the DevOps Promise. DevOps is a term we hear tossed around daily. It encompasses tools and practices that break down the silos between our teams, help them create, deliver, and deploy applications and services faster than ever before. Previously, organizations only released a few times a year. As you can see with our modern practices, they can be pushed out releases in a matter of weeks or days. However, for most organizations, the reality has been really different. To fulfill this promise, they've needed to align their teams to the pipeline and equip them with automated tools to maximize the velocity. While this has been achieved in some in continuous integration and delivery stages, there hasn't been that kind of automation in that continuous deployment. So unable to automate that last leg of that pipeline, many organizations turn to their own real option, which is people. And at the end of this automation chain, we basically see an operator who've set aside whatever they're doing or where they're doing to basically manage the actions requested by that ticketing system to push things along. So if they're missing some information, the service could end up held for weeks, days, and sometimes longer. So furthermore, if they mistakenly input some incorrect information, that could result in misconfiguration and lead to outages or inadvertently create an attack vector. So three main challenges that we see, and if we can distill all of that for enterprises, we break them down into these three main areas. So there's increased risks. Network outages and performance issues are usually caused by human-driven misconfiguration. Secondly, slow processes. I know if I want to deploy a new service, traditional ticketing-based systems create bottlenecks, consuming valuable resources of our teams, and decelerating really that deployment rate of our applications and services. And thirdly, there's no standardization. So achieving end-to-end automation requires that reproducible systems in place that abide by the company's best practice. And what we typically refer to that term as is network infrastructure automation. It's emerged as a broader solution to help organizations address these challenges we've just described. And with that, I'm just going to hand over to Tony now to dig into our CTS solution. Over to you, Tony.
Thanks, Ilch. Let's break down the components now of network infrastructure automation, and we'll look at some of the maturity patterns. With this, we're gonna look at day 0, day 1, and that typically happens through infrastructure as code, IAC. That solves some of the challenges today with inconsistent configuration, repeatability. Teams using Terraform can quickly establish repeatable infrastructure through provisioning, compliance, and management across multi and hybrid clouds. Day 2 focuses on dynamic service network automation and eliminates dependency on manual-based ticket systems, right? So using the Terraform provider and ecosystem, we're able to integrate with Consul so we can deliver true end-to-end automation. So if we look at some of the maturity patterns, we first have a traditional approach, which is where a user logs an ITSM ticket and it gets routed to various teams who actually are responsible for each of their technologies in their own domains. So you have individual network teams, security team, load balancing teams, and so forth. So when someone requests a deployment or infrastructure, each of those teams are responsible for configuring them, and they may happen manually in that scenario before the user gets a successful deployment. This could take days, weeks, but it takes a considerable amount of time. When someone wants to make a day 2 change to that, again, that process is almost restarted, rerouted back to an ITSM platform, and then someone has to again relog that ticket, and it goes through that manual process. A common approach today is actually using Terraform, and we're all familiar with this. You may have advanced and mature users who do this end-to-end, all the way from virtual machine deployments all the way to network security and load balancing. However, enterprises, or the reality for enterprises, this is still challenging. You still have separate teams who manage each their own devices and services. So if we take the bottom workflow example using Terraform, the user will log or deploy Terraform code. They'll get a successful deployment, but often for enterprises, they may be still missing components such as the right security group or security policies, or the load balancing or load balancers haven't been created for that deployment. So that user will need to again go through that same process of a ticket-based system and log that request. Similarly, day 2 changes are challenging as well. They would need to, again, if they want to scale out or scale in or make a reconfiguration change to that deployment, they would need to log a ticket. So we look specifically today, network infrastructure automation, or known as Consul-Terraform-Sync, day 2, is this new capability which allows us to subscribe to Consul's catalog and automate networking tasks based on service changes using Terraform. So it removes any intervention or any human element and can create a consistent way for managing network tasks. So let's do a quick conceptual walkthrough of how CTS works. Very simply, when a platform team or user or consumer deploys a new service, it gets registered with Consul automatically. Consul-Terraform-Sync picks up that new service instance and then follows a task definition to create or update a load balancer. It could be a firewall. It could be essentially anything with a Terraform provider or module. Terraform then executes this with variables passed from Consul and completes that automation end to end. So I guess what differentiates CTS is its ability to utilize Terraform's automation capabilities to update network infrastructure or changes registered in Consul service catalog, making it possible to accomplish what used to take days, weeks, in literally minutes. So let me walk you through and let's see this in action. I'm just going to transition to my desktop. Okay. So you see my desktop now. Let's walk through what I have in this deployment. So what I have is a simple environment built on AWS with some EC2 workloads. I have a Consul server. I have an F5 big IP. This is the load balancer provider that I'm going to use. And I have some Nginx instances that are part of a auto-scaling group. So what I want to actually demonstrate is a service change where I have an existing environment with 2 instances in this auto-scaling group. You can see the front-end application now refreshing against those 2 instances, and you can see the IP address change automatically every few seconds. What I'm going to do is essentially invoke a change to auto-scale this up to 4 instances. All right, and we can see Consul-Terraform-Sync update the load balancer. But before I do that, let's walk through some of the components like Consul. So this is the Consul UI, and a Consul can be managed through UI like you see here. It can be programmed through an API, or it can be managed through a CLI as well, right? And we have 2 services, 2 Nginx services registered. You can see their IP address here, which represent the IP addresses of the Nginx services here. So they're the same IPs, and we have 2 of them at the moment. Inside, Consul is also monitoring the health of these services. You can see here it's doing a lookup and a TCP check on port 80, and they're successful. So if we had multiple services here, and one of them became unhealthy because the service went down, Consul will actually see that and actually remove it from service. And also CTS, or Consul-Terraform-Sync, will actually remove that from the load balancer as well. All right. We have our F5 appliance here. You can see if I go into the virtual service and I have a look at the nodes currently listed. Let me just move across to there. You can see I have the 2 nodes. They're running today as per my Hello World application. In my network map, let me just refresh that as well. And I'll just go there. You can see that the 2 services there as well. So that's my environment. Just to summarize, it's a pre-existing environment built on AWS with Consul running an F5 and some Nginx services. already being load balanced. So if I look at my code here, this is my Terraform code. This is my Nginx code here, which is my autoscaling group resource. Desired state is 2 at the moment. I will change that in a little bit. But before I do that, let me walk you through Consul-Terraform-Sync and what that looks like. So with Consul-Terraform-Sync, I have a configuration item here. All right, and this is, I have a Terraform driver, which is essentially responsible for listing the providers that are required, the provider that I'm going to use, and the tasks. So with the task is essentially a block that allows us to specify automation or conditions to execute against. So in this instance, I am looking at all Nginx services that are registered in my console catalog, and I'll be running the big IP example Terraform code against that. So this is my big IP Terraform code, essentially which translates the input of variables passed through console and executes against. So I'll go through this in a little bit more detail in a little bit, but essentially Consul-Terraform-Sync runs as a binary. It monitors the state of console for any service changes and it executes Terraform code. So let's make some changes now. Let's go to my Nginx service and let's change that desired state to 4. I'm just going to save that and I'm just going to run a Terraform plan. See the output of that. Why I do that, on the right hand side here, these are the events of Consul-Terraform-Sync. I call it CTS. If you hear me say that CTS or Consul-Terraform-Sync, they're the same thing. But these are the event logs where I can track any service changes. So we're going to keep an eye on a few things here. I'm just doing a Terraform plan at the moment, and then I'll do an apply. All right, so I'm going to make one change, and it's essentially the change to the desired capacity of that auto scaling group. If there's any questions, put it in the Q&A and I'll come to them at the end. I'm going to accept these changes. And why we do that, let's monitor the console UI as well for these services to appear. So we'll just take a couple of seconds. We'll keep an eye on the console services and we'll keep an eye on Consul-Terraform-Sync's output as well, and we'll see those changes. So what's happening here is we're auto-scaling that Nginx service. It's building 2 additional nodes to bring it to that desired capacity of 4. What we'll see is that change is successful now, and what we'll see is the services will be automatically registered against Consul's service catalog. Console will start immediately health checking those services, and then Consul-Terraform-Sync will invoke and update the F5 load balancers in this instance. We can see now the services are starting to appear. The services are not healthy yet. At the moment, we're waiting for the TCP check on port 80 to happen, but we'll keep an eye on that. The other services also appeared now as well. So we can in fact see that Consul-Terraform-Sync or CTS has already executed. It happens, actually the modification completed after 0 seconds. See some of the inputs that are passed across from the logs. So usually you have this as a background service, but it actually runs in real time like we just saw, right? This executed and 21 passed, and we're getting some more execution now on the second task that's coming up. So once the services are healthy and they're up, CTS will see those changes and execute against that. All right, so that's complete now. So if we go to our F5, if I refresh the network map, we can now see 4 in the load balancer pool. If we go to, if I refresh the node list as well, I can see 4 services there. Similarly, if I go to the front end or the hello world page, I can see this change across 4 different services. So that's what's happened. I've made a change as a user to my Terraform code. I've auto scaled it up, and automatically CTS, or Consul-Terraform-Sync, has picked up those changes, and it'll pick up those new instances that are registered in the console, invoked Terraform, and updated my load balancer for me. So let me show you something else as well. We have a folder called sync tasks, which is what CTS creates. And we can see the inputs or the variables passed from console service catalog across. All right, so these are inputs that are passed to Terraform, which is using the F5 big IP provider and resource to make those changes. Now, similarly, if I scale this down, we're going to see the reverse of this. We're going to see the instances being removed from console, and then we're going to see CTS actually see those changes and remove it from load balancing as well. But I'm going to do something different here and not use Terraform. Ideally, we do use Terraform, but in some instances, separate, we can see if we make a change to the actual auto scaling group itself. And I go to 2. This change is picked up by console service registry. I'll just bring the logs back up. We're going to see that change, and we're going to see the instances disappear, and we'll see CTS rerun and actually remove those instances. Okay, so we saw these services are being spun down now and terminated. And again, we can see some changes in the in CTS's console output. All right, we just wait for that to disappear. There, it's gone now. So again, if we refresh the node list, down to 2, same thing here, and we can see this is only refreshing against 2 now. So that itself is a very quick way or quick demo of CTS. Let me just go back to the presentation. So what we've just seen here essentially removed some of the components or allowed end-to-end automation from the networks team. And this also allows the networks team to manage their own Terraform code, which configures their own devices like the F5 I just demonstrated, or their own firewalls as well. So it gives this ability for different teams to automate and different teams to manage their own devices from a compliance point of view, from a people point of view, but enables end-to-end automation. So what we've just seen here is essentially workloads being initially deployed through Terraform, but then day 2 changes being picked up in the service registry. And it allows operators to define different automation tasks and subscribe to them so that those devices can be updated or configured through CTS. So each of those tasks consists like you saw, of a run book written as a Terraform module, using resources and data from the underlying network infrastructure. In essence, when a service change is detected, you saw CTS execute against those tasks or that task block. Those task blocks that I demonstrated can be fine-grained. You can associate different tags or leverage different metadata in Console to drive different automation aspects. What this does is, or what CTS does for Terraform, and this works on Terraform Cloud and Terraform Enterprise as well, it reduces misconfiguration, it reduces configuration information passed between different humans as well. With Terraform Cloud, you can actually leverage automation approvals, so you can set notification triggers to inform a team when a predetermined event occurs. They can quickly review that before any configuration is applied, and that happens within just a few clicks. Automatically catalog changes to the environment can be audit logged as well. This provides the ability to comprehensively provide forensic trail to keep compliance teams in the loop and analyze any issues as they arise as well. So Workday adopted this, were one of the early adopters of CTS. There's a few webinars that we can share, but it enabled them to deploy changes in minutes, whereas in the past it took them days. And this is a quote they shared with us. So just to summarize some of the outcomes that we demonstrated today with Consul-Terraform-Sync, before it was very manual-driven, ticket-based. You had multiple teams, you had multiple engineers involved. It would take, days, weeks, depending on the workload as well, depending if there's change approval processes. There was a lot of wasted resources. There was a lot of time handoff between different teams as each component got configured when it wasn't built end to end. With Terraform-Sync, there was no manual human intervention involved. Provisioning time took a couple seconds. And there's automatic cleanup as well. So we leverage Console as a registry where all the services that get spin up or changed as a source of truth. And then Consul-Terraform-Sync executes based on that. So there are a number of ecosystem of providers. There are A10 providers, there's AWS, Checkpoint, VMware, Cisco, Citrix, F5 like we saw today, Palo Alto, and S1. You can use custom providers as well, and custom modules. So Terraform has a registry with a rich ecosystem of providers that you can leverage to meet any organization's requirements. So I hope that that's been useful. If there's any questions, please put them in the chats. Ilch, I'll hand back over to you.
Thanks for that, Tony. I'll turn on my camera. Thanks for that, Tony. Look, that was a great presentation and demo. I certainly enjoyed it. We do have a couple of questions that I'll pick. I might go to Eng He Yao's question. In the Terraform provider code, I noticed that the password and ID are exposed. Is this secure? Now, I kind of know the answer to that, but I might let you answer that question.
Yes, so they are exposed, but this is that is not secure. And I have purposely outputted that to the console so I could essentially access them easily. But that's not something you want to do in production. By any means, it's purely for my demo. At the same time, I've exposed them in the UI because sometimes I like the audience, could put them in the chat to access the services as well and have a play around with it. But essentially, no, that is not what you want to do.
We've got another question here from Bunchu, basically asking if they can have this example repo for review. That's something that you can share.
Absolutely. We can share this repo. I'll put it in the chat right now. It is a public repo. I've put the repo that I've used to build the environment today in the chat channel. One of the requirements are obviously to use your own AWS key and access, but that's the same demo or same piece of code using Terraform that we instantiate the F5 device, CTS, and the Nginx devices or instances. Let me just repaste that to everybody. There we go.
Thanks for that, Tony. Look, we have another question here from an attendee. We're running Vagrant/Terraform at the moment to coordinate application of a lot of modules. Can this work with Consul, or will I need to be removing our use of Vagrant?
So I would need to, apologies, I don't have a deep enough understanding of Vagrant to answer that right now, but what we'll do, Brian, is we'll reach out and offline and have a separate conversation around this. If you're leveraging Terraform already, and a lot of our customers who leverage Terraform, it's a small step to start looking at CTS, Consul-Terraform-Sync, to enable that. We try to leverage what you have today in terms of Terraform modules or Terraform code. And what we're doing there is executing that based on service changes. So it's not a big step.
There's another question here. Is Consul-Terraform-Sync available on both open source and enterprise? I can answer that. So basically, Consul-Terraform-Sync is available on both enterprise and open source. And there are, it's also available on Terraform Cloud for Business. So there's a nice integration with both of those that leverages some of the enterprise features of Terraform. So, think Sentinel, Control, etc. So they're both widely available. We've got a few more minutes. There's another question here. Can we use it to leverage existing infrastructure in Azure? There's no further detail there.
So maybe maybe we could expand on that, but the way I read that question is, can we leverage it to automate existing infrastructure in Azure? And if it is that question, absolutely. So if we go back to the slides with the ecosystem of partners, we focused on network infrastructure automation today, and those network devices like F5, Palo Alto, A10, and so forth. But absolutely, CTS can leverage any Terraform provider and execute against that.
Thanks for that question, Naeem. So, and I think, it was just got to do with that omission from the slide. So I think the ecosystem partners, so some customers are leveraging CTS to reach out to some of those traditional load balancer infrastructure vendors. So essentially, CTS can automate anything Terraform can automate. You can just think of it that way. It's particularly useful for deploying the last mile, as we referred to in our presentation today. I'm just going to wait for a couple of minutes to see if there's any other questions. Well, folks, that brings us to the end of our session today. We hope you found it useful. As I mentioned earlier, this session was recorded, and we'll send you the link to the recording in an email shortly. If you like what you heard today and want to learn more about Consul-Terraform-Sync, please visit the Learn pages on our website, which you can find at learn.hashicorp.com. Thanks again for joining us today, and a big thank you once again to Tony for presenting. Enjoy the rest of your day, and bye for now.
Thank you.